Hey everybody, this is Larry. This is day 23 of the August Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. So yesterday's poem was a easier one, the first one, a bounding box. I don't know what this one is, but I guess we will see. I don't remember it, and maybe I should have looked, I mean, I could have looked it up, but that kills the point, so we'll see. But yeah, but before we start today, I want to get a point of my workout. And I think one thing that I didn't emphasize this year yet, or this workout session or training session or whatever, is that I ran like 6 miles easy, and then took a nap, really good nap that took like I don't know a couple of hours. But I feel fresh now, hopefully, and it sounds that way. Though yeah, I think one thing that I often see, I want to give a little bit of a intro thing. Definitely feel free to fast forward or watch on 2x if you're here just for a solution. Though I have another video for this anyway. Probably. I mean, it's 3197. This means it was a contest problem not that long ago. So I think one thing that I often get on my Discord, and I've had this Discord and this channel and stuff like that for 5-6 years now, which is actually a long time. Now that I think about it, I don't know. That is a crazy long time, isn't it? But in any case, my thing about this is that what the top thing that I've here is I want to get to Knight. I want to get to, a Leetcode ranking Knight for contest, or what's the other one, Guardian or Knight or something like that. I don't remember what the number labels are, but or some number, right? Like, oh, I want to hit 2,000 rating, 2,500 rating, whatever it is, right? 1,500, I don't know, whatever it is. And I think those are nice goals to have per se, but it's really hard to kind of know where your body or your mind or whatever will take it, right? I mean, a lot of it depends on how in shape you are with all these things, just in terms of your history, right? What I mean by that is that, okay, like, I'm using running as a explanation because there's something that I've been doing, struggling with, if you will, working on it, if you will, these days. Is that you always, sometimes you hear people like, oh, this is my first marathon and I run a sub 3, which is, by the way, very, very good. But it's like, yes, but that's just because you haven't done a marathon yet, because they've done like, and you hear about them, and it's always like, oh yeah, I used to train for like years, just not at that distance or something, right? So there's a lot of parallel. And the same thing with like Leetcode and competitive programming and stuff like that, right? Is that you hear people like, oh yeah, they just kind of there's the first 2 months and they're or whatever it is, and they're already a grandmaster or red, whatever it is, right? And the short answer is because look, they spent like a decade doing math problems or whatever. Yeah, it's not the same, but for the purpose of competitive programming, there is a lot of overlap, right? I think people can at least at the higher level, right? So it's the same thing, right? So all these things, you look at people and it's just okay. I mean, at the very least, like I've only started running last year, right? I mean, I ran a little bit before, just like playing sports and stuff, but not long distance, not even really running. And COVID also just makes it so that I didn't do that much. So it was, pretty much from scratch, right? Is what I mean. And so, like, it would be very silly for me to be like, oh, I want to have a sub 3 go, because the people who do sub 3, they're impressive not because they're able to do it. I mean, that's part of it, but it's also impressive because it also means that they've already put in years of hours and hours of years and whatever of work, right? Yeah, I mean, maybe it's and it's even tougher for you if you think about it in a way, because because you're trying to squeeze everything in like X months or X year, right? Where they've been just, maybe they started way early, maybe at like 10 or something, and then they don't do that much. They spend like a little bit of time a day or a week, but because they've done it for 10 years, they're just like a lot of good shape, right? And just all accumulating, even if they add up slowly, if you will. Same thing with Leetcode. And it's just like, yeah, I mean, if you're, and there is a selection bias too, right? Like, you no disrespect, if you already started out, you're very strong, you're probably not watching this channel in any case. So, I'm here for the rest of you. Is that, I mean, a lot of these people spend years doing like funky math problems. It took me, and I don't like to brag about these things because I don't think it matters. But just in the context of what we're doing, right, is that I was read in Top Coder, which is I don't know. There are no labels in Top Coder, just colors. It took me like 7 years or something, right? 6-7 years. And of course, just to be clear, like it wasn't like I was studying hard every year or every day or whatever for 7 years. It was just, there are a lot of, what I would call, the equivalent to what, if you were in the gym, people would say, oh, you're just messing around in the gym. And yeah, like I was doing that for a little bit, a couple of years as well. Because, I don't know. And then just kind of got into it eventually. But it's the same thing, right? So anyway, my whole spiel there is that it's good to have goals, it's good to have sight, right? It's good to have dreams, but figure out what it is that you can control, right? We do Leetcode problems, and you know what? Critical parts of the Leetcode problems, inputs and outputs, right? You can't always control how your body, your mind, or whatever will take to learning. Some people are just good at A, some people are good at B, but a lot of the things I would also say that like same with running, right? Like, yeah, if I'd done everything right, would I be in the Olympics? No, I don't think so, honestly, right? Like those are like top 20 people or whatever, or I don't know, whatever, right? Top X for some X. I think even if everything went right, I don't think I could have gone there. But if the goal is like, oh, can I run a 4-hour marathon, or maybe even an hour and a half, or or maybe run a 7-minute mile. Yeah, I mean, these are things that are that you can have input into, and it's just what I call a progress goal, right? I mean, I didn't coin that term, just to be clear. A process goal, right? Meaning that you can't control how much how in shape you get or whatever necessarily, but you can control going to the gym every day. You can control doing Leetcode every day, or even like 4 days a week, right? It doesn't have to be every day. I feel like streaks are overrated. I have a video about that, but it's just you could control doing a Leetcode problem every other day, right? You could. So these are the things that I want you to think about. These are input goals, and then everything else. They'll come out. I mean, I think the only other thing that I would say about that is that, at least for now, because I talk a lot, is that just make sure you're not messing around, right? Like if you're doing a easy problem and that's genuinely easy for you, right? And you're only doing one to quote unquote continue the streak, or to make the process go. And honestly, I'm doing this a little bit with Duolingo, where like I know I'm not learning, but I'm just doing it for the streak. Which is not that's not quite the same as the process go. You still have to put in effort. Like if you, I mean, it's better than nothing for sure. But think about if I actually learned a little bit. If I learned one in Espanol, if I learned one vocabulary word a day, over I mean it's not a lot, but over a year that's almost 400 new words, right? And then over 2 years it's 800 new words. And I don't know what they say about Spanish, but I feel like in English there's something like they say something like if you know like 2,000 words or something, you're able to say most of the things you want to say or something like that. Don't call me on this one, just Google it. It's very easy, or ChatGPT it. I don't know. Like these things are very easy to find, but I just it's just off my head, right? So very much to be wrong, but you get the point, right? Is that make sure that your process go, and it's okay to have rest days where you don't make progress, right? Like maybe you're having another dimension, right? Meaning that, for example, maybe you know that today you're going to do a easy problem, you know that you're going to do it, but you want to work on your speed, right? For me, for example, in running, like I have easy days, And with easy days, I don't necessarily, you're supposed to, the idea behind easy days is letting your body recover a little bit, but also reminding that it wants to work. I mean, there's more science about that. I know that sounds a little bit woo-woo, but a little bit more science about that, but just to kind of, keep it fresh, if you will, keep it moving. But where a lot of people struggle with marathon training is that they run the easy too hard because and as a result they're not letting their body recover, right? And for me, so I just have other goals instead for those training. I mean, I keep track of my heart rate, I keep track of my percentage and by heart rate zone, which I know it's not 100% either, but anyway. And try to keep it as low as possible. And how do I keep it as low as possible? Well, I try to be as efficient with my form, right? Like when you're running hard, sometimes you get a little bit sloppy with your form because you're running hard. But if you're trying to run easy, try to you run tight, it affects your heart rate. If you are making exaggerated movements, you're trying to be as efficient as possible. And that factors into your heart rate, for example. And for me, it's even just my shoulder positions and shoulder tightness, how much I swing my arms, a lot of little things that I work on during my quote-unquote easy run, right? And it's to keep my body easy, my legs easy, but just to also, it's what people also call runner's economy, even though I think people also just get better over time, even without being as deliberate and conscious about it as I am, but yeah. Anyway, this is a long intro for a hard problem, so I hope this video isn't too long. I don't know what this problem is yet, really, right? I mean, I read the title, but so hopefully that's you can incorporate what I said into your training / getting better at these Leetcode things, right? All right, we're 12 minutes in, so let's get started. But let me take a sip of water. Let's read this together. I'm not out loud because I'm drinking water. So let's go. 3197. Okay, 3 non-overlapping rectangles. I mean, first of all, this is kind of already it has a very much feel of like an MP type problem, and what I mean by that is complexity hard because it's just but the key thing to note, or is the first thing I had to know, maybe it's a very elementary thing, is that there are only 3 of them, and 3 of them is special for some particular reasons. Let me bring up my drawing board real quick. And I don't know if this is useful yet, right? With these videos, this is a hard problem, so sometimes I get more views, but as a result, I also get more new to my channel video. And the thing is that all these is live. Sometimes I have an idea just from experience, but I don't know the answer yet, right? So if you want someone who explains it to you perfectly because they just clicked on the solution or an editorial, then go do that. But for me, this is live. I go over my thought process. Sometimes they're right, sometimes they're wrong. I want to, but I think for me, the steps matter, right? So I don't know, or maybe it's just helpful. Anyway, my thing about the 3 overlapping is that let's say you have a grid. Well, let's go for 4 overlapping for a sec, right? The thing about 4 overlapping is that you can maybe do something like this. I'm not gonna get this right because colors is hard, or drawing is hard, right? Maybe I'll draw this underneath instead. So let's say you have a red underneath, and then a blue underneath that, and then you have a purple that's this is pink actually, but that's on top of this. So you have basically a cycle thing. So this is actually on top, so you can maybe just remove this, right? So you have kind of a cycle looking thing, and this is what the number 3 is important for, right? Because 3 means that you cannot do this. That means that one is on top of another, on top of another. Again, I don't know if this is relevant, honestly. We will see if it is, but when we're talking about overlapping things and 3 things, this is the first thing I noticed. The second thing to look at is that, like I said, this is fused by NPE. So gotta look at the constraints. Can we do anything dynamic programming-y? Okay. I mean, all times C is 300, or ends, or all is no. Let me say it again. The number of rows is less than 30. The number of columns is less than 30 or less than equal to. So all times C is 900, which is kind of big, right? So, and so you could do n square, n being all times C. You could do n squared, but you cannot do n cubed, which is annoying because we have three things and not two. But some things to think about, right? That means that at the very least we can think about it that much. Okay. Now, okay. But I guess that's the only thing I can to get us kicked off. And the reason I would say that is that I said this about the Q4 from the contest too, which is that the descriptions is very simple, very straightforward, meaning that it is if I don't have an immediate idea about it, I haven't seen it yet, maybe, or whatever. Though I definitely have seen it because I solved it, but I just don't remember it. Then that means that it's going to be a tricky problem. And that means that for me, we have to kind of think about it, right? All right. So anyway, so these are the things that I think about. One of the first ideas that I have in general about, well, maybe not in general, but at least for this one, is simplify a little bit, right? And they don't always generalize, but simplifying it at least allows me to kind of have an idea of like just visualizing in a way. And okay, maybe what happens if this is instead of a 2D, we have 1D, right? Well, with 1D, I think it's, well, actually, I was gonna say it's pretty straightforward, but is it? Because then now, but 1D is a sub-problem of this, so we have to figure out, right? I guess this is, well, with 1D, this would just be dynamic programming, right? Because then you're taking advantage of the fact that we have only 3 rectangles. If we have any number of rectangles, I guess it's n squared. Well, if we have enough rectangles, you just put a rectangle inside each one. Yeah. But otherwise, it's going to be k times n, where k is the number of triangles, and you have dynamic programming, right? Yeah, the idea, and I don't know if I want to explain it too much because it may not be the right path. But the idea there is just, doing a recode. I mean, it's going to be k times n space, but probably k times n square. Just if you do like a for loop inside, and each for loop we create one one rectangle, right? So okay. So if it's 1D, it's going to be k times n squared. Can we do the same thing for 2D? Not so easily. I'm thinking of that problem that we did the other day about compressing stuff. But you don't need everything to be all one, so I think that's a little bit trickier. Well, okay. Let me step back for a second, right? I know I drew the thing with the overlapping thing, which, let me bring it back up real quick. I know I drew this thing, which is, I don't know, maybe it's kind of cool, maybe it's not. But I think another thing that I realized from here is that if you only have 3, if you have stuff under, no, that's not true. Actually, I take that back. I was going to say that now you could decompose them into non-overlapping. But that's not quite right? Because you can imagine, unless I misread it somehow. Yeah, no, I don't think so. You can have something like this, right? And in this case, then of course, you can still decompose them, but not into 2 pieces. Meaning, if I only look at the black and the red, there are 2 pieces, but 2 initial pieces, but no, no, because the black could go down as well, right? So you extend it, then now you have at least 3 pieces no matter how you slice it. Okay. Yeah, so I don't know. So we can decompose them. I was thinking of maybe something along those lines, and then thinking of like maybe, yeah. Can I think about stuff in bounding box? This is a very hard problem. I have no idea, by the way. Very often I do, but like in the other problems that you've seen me solve, maybe. And today I have no idea, so we'll explore this together. And with that, I'm gonna get a quick water. Another one. Gotta stay hydrated. Oh, I am dumb, am I? I missed the non-overlapping part. I even drew stuff about overlapping. Oh man, what am I doing now? This is what happens when you don't read it out loud, I suppose, because I was drinking water. And we went on about like 10 minutes about it. Alright. What does non-overlapping mean then? Huh? Okay, sorry friends, if you're watching so far. I don't think fundamentally changes that much from everything else that I've said so far. Though I mean the one-dimensional version, non-overlapping. Yeah, the non-overlapping is actually much. I mean, it's the same DP for one-dimensional version. Still k times n squared, I think. Maybe it's a little bit better, or maybe there's some crazy thing. But okay, for 2D, what does it mean? Well, I'm thinking of the bounding box thing that we talked about yesterday. Yesterday, right? Yeah. And I'm just trying to think. Well, I mean, I think it's just brute force in a way. Maybe. Let's see. Right, bring back the drawing. Hang on. Because they're non-overlapping, and some of that maybe is just from experience. I don't know that I think that fast or whatever. But because what I mean is, I don't like to delete this because it's so pretty. I drew pretty. It's not that pretty. But no. Okay, so then now we've got 3. The key thing about 3 things, and they're not overlapping, then, is that the combinatorial is easier, right? Meaning that, well, if you have 3 things, then there really only a couple of possibilities. There's this, and then maybe the mirror image, obviously, and then maybe the rotation, and then that's it, right? Are these all? So I guess there's just 4 ways of doing it, right? There's no like, yeah. I mean, obviously you have to loop through these things, but then now, right? So okay. So the 4 for each slice, if you will, there's 4 orientation, but that, just rotate them 3 times or whatever the original one. But that also means that we can maybe figure out how to brute force it, right? In that that means that given 3 pieces, 3 things, the idea here, and I'm maybe thinking to myself versus articulating well, which is my apologies, is that once you separate the 3 pieces at once, then we could shrink wrap it, right? And then the way to get the answer then is to brute force on what these divisions are. And because there are only 2 lines for division for 3 things, that means that, well, here it's going to be one side. Oh, I mean, sorry, I messed up because there's obviously the other possibility of just, this as a division. And maybe I just went too fast and forgot to mention it. Like bounding boxes, right? I mean, here the math is also, it's kind of, the math is mostly the same, right? But, which is that, yeah, if you kind of just think, and for me right now, I'm just thinking about complexity and whether I can do it fast enough. maybe or at least even feasible, right? Like for example, with n cube, then it's not even close to feasible. Like there's no optimization that could do it, right? So so I don't even think about it. But yeah, but this line, I mean, okay, let's this one's a little bit easier, so let's analyze this one first. So you have these two lines. This line goes up and down. What's it? Is it 30? Yeah, so there are only two lines and they go each 30 times 30, so there's only 900 possibilities for this one. Rotate it twice, right? I mean, you can rotate it more than once, but then it's just for symmetry reasons. And even then, technically, this isn't 900, it's 30 choose 2, which is more like 900 over 2. So you could even divide this out maybe, but that's getting a little bit too precise. I just want to get back of the envelope things, right? Anyway, so it's 900 times 2, and then for each one, can we get the bounding box in O of 1? I don't know. Right? But do we even need to in this case? I mean, we still should try, but even if this is 900, that means that at worst this is going to be 900 times 2 times 900, which is going to be fast enough, right? And then now let's think about the scenario that we kind of skipped a little bit, and then go again. This one goes, this line goes, there's only 30 possibilities. This is also 30. So this one is more, this is actually 900, right? Because of the way it's structured. Maybe -1 or whatever, but you get the idea. So this is actually 900, but this is times 4 for the 4 rotation. And then each one again, maybe we do some bounding box stuff. It's gonna be, but that's only 4 million. I mean, it's even less than 4 million really, but I say 4 million because 1,000 times 1,000 times 4, right, is 4 million, so it's less than 4 million. So that means that this is good, and we are just in brute force, maybe dynamic programming. I don't even know if you need dynamic programming, but you can definitely save boxes, which has whatchamacallit, an upper left and a bottom right. Upper left has 900 possibilities. Again, it's not really 900. It's like 30 squares ish, and then the right corner also have just there are 900 square numbers of possible rectangles, and when you save the bounding box, so that's just the number of things. Yeah, and if you could even pre-calc this, right? Maybe with sliding windows or maybe something like that. But you don't even have to. That will make everything O of 1 for each thing, so that is going to be fast enough, right? Yeah. Okay. I mean, I think that's enough for me. I mean, maybe I'm a little bit off, and honestly, maybe I'm just wrong because it's very easy to miss things for me. But that's enough for me to have at least a proof of concept of, okay, there is a way that this is fast enough. And if that's true, then we should be able, YOLO implement it. And here we are 20 minutes in. And of course, though, I wasted the first 10 minutes because I misunderstood the problem or just misread it or missed a word not just bread in India, right? So yeah, let's get to it. Maybe we pre-calc the bounding boxes. And this is, I think some of it is that I think of it this way is because I thought about a problem yesterday, and that's how I would have done it, right? We do have to solve the bounding box in a cleaner way. Maybe I was a little bit sloppy, actually. Actually, I think I messed up a little bit in my analysis, because I said that there are 900 times 900 corners, so that is just 900 choose 2 corners, so that's less than a million, and that's fine. But then if you do it naively and you loop through the thing to get the bounding boxes, that's not good, right? So we have to kind of, because then now it's 900 square for the number of bounding boxes, but then each of them you're taking, I don't know, O of n, it's going to be too slow, right? I'm just trying to think. Actually, I mean, I think one thing that I'm trying to think right now is my analysis before I kind of continue. And the reason why is that because I was very lazy on this analysis and it seemed fast enough either way. But one key thing to note is that not all these states are possible, right? I mean, I said 900 square, but the way that we construct these ideas, you cannot have a square in the middle, right? And maybe that is one of the things with, yeah, with just 3 boxes as well, 3 regions, is that there's no possible things in the middle. What does that mean? That means that for each of these boxes, we always have one, that means that we always have one of the sides touching the like there's no interior square, right? And I'm just, or interior rectangle. And that means that, what does that mean? Well, that means that for one of the boxes, okay, so, well, let me break it down in a little more precisely, right? Because I've been a little bit hand wavy because I thought it was fast enough, but maybe we don't have to do bounding box for all of them, because a lot of them are not going to be used because, as I said, there are no interior rectangles to use. And as a result of these saying that each rectangle that we broke apart according to sides, in fact, because of these, it means that at least, I mean, there's this case as well. That's why I'm like hesitating to generalize too quickly. But I just stick with this kind of breakdown is that, you have these ideas of corners. And what does these corners mean? That means that it is fixed, right? Meaning that for this rectangle, you have one corner that's fixed, so that means that you're only moving this corner, and that means that is 90 times 90, right? Or 30 times 30, 900, sorry. So that means that for the lower right is 900 possibility. For upper right is the same idea, is that only 900 square, 30 square 900 possibilities, right? Because it only matters what this corner is. And for this one, you have 2 corners, which actually is 2 fixed. That means that, in fact, there's only 30 possibilities, only one dimensional to change, right? So that means that in the worst case is we have 1 corner, and we have 1 corner when we have 30 squares. So what I was going to do, and going back to quick, and I'm lucky that I kind of caught it because it's a little bit slow otherwise. What I was going to do is like for x1 in range of r, for x, I guess it doesn't matter which order you write it, but for x2 in range of x1, r1, what? No. For y2 in range of y1 to c, right? And then calculate bounding box. And like I said, maybe I was thinking of bounding boxes because of yesterday's problem, and this is slow, right? Because this is 900, this is 900, and then if we do calculating box without sliding window, and I was thinking about sliding window and all these other weird, crazy ideas, but that's going to be still like all of another 900, which is linear in the size of in the rectangle, right? But now that we think about it a little bit with this perspective, they're never interior rectangles, so we never need to care about all of them. So that we can just calculate them on demand because there are not that many of them, right? And then you can also go for the other case, right? Where you have 2 triangles. Oh, sorry, I keep saying triangles, I don't know why. But 2 rectangles in which they're fixed. So that means that there are only 30 possible things. I mean, times 2 because of rotation. And also up here, you could say there's some parts of rotation, but there's a lot reused in either case. But yeah, so there's 30 to 30. And then you could even say here, the 2 movability, so it's at most 30 square. So same thing as before. If it's 30 square, it's 900, and then you do a linear bounding box calculation, and that's another 900. That's less than a million, right? Which is, maybe it could be better, but it is fast enough. So okay, So I think now, and I really liked or was going to write like a pre-calculation thing just because usually it speeds things up with dynamic programming. But in this case, if, at least the way that I would have written it, I mean, we could still do it, but I don't know. I don't think it changes anything the way, depending on how you write it. It's just also a little bit trickier to write because instead of just slapping on a memo thing and just have memorization doing it. But yeah. But yeah, okay. No. Bounding boxes. Okay, I just want to make sure that I'm showing you the video because sometimes I forget to take a video. Okay, but now I feel a little bit happy with the analysis. Like before, maybe I was a little bit too hand wavy. But yeah. I mean, so that's the idea, clearly. But that doesn't make the implementation easy, which is why I'm thinking how I want to structure it. I mean, I guess just standard dynamic programming, I suppose. See, make it inclusive. We have 3 triangles, right? Or I keep saying triangles, rectangles. And let's just slap a cache on it. I'm not going over dynamic programming today, or at least not the basics of dynamic programming. Something like that, right? And we could maybe establish some preconditions. Whoops. Right? Okay. And then if f is equal to 0, then we just return 0. Otherwise, we okay. So then given the I guess given any rectangle that we're given so far, we only have 2 choices, right? We go from the top down or from the left to the right, right? So here, slice off the top maybe. So we go for I in range from x1 to x2 plus 1, so that's inclusive. We slice it off, so then we get I plus 1. Yeah, y1, that hasn't changed. And right now, clearly, I am just thinking about the cases, right? I mean, technically this is right, but it's because it's not precise enough. That's why I'm struggling a little bit. And the reason why I say that is because if I do it always in this direction, I'm going on the drawing board again because this is a very visual problem. Maybe I should have saved it before I erased it. But in any case, yeah. Because what I was going to do is that I sweep down, right? So it goes to and then I also sweep right. So yeah, we cut it this way, right? But the problem with this is that if I did it this way, I would have missed the case in which it looks like this, right? Well, yeah. I mean, I guess you can write it in a way such that, but if you always do a left -1 thing, because I guess we can't. Or maybe even I mean, I guess you could take the slice that you have and then just do both of them. But I don't know. I mean, I think as long as you find a way to do it, it's fine. But for me, maybe the way that I want to do it is also slice bottom and to the right. I guess that's the same thing, really, right? Because it's the same sweep line. Okay, fine. So then we sweep on going down, But instead of always just slicing one off, we can also try keeping 2 in one port and 1 here. So we basically try both these scenarios. Okay, I mean, we'll go over it in code, but again, so don't worry. But I think I'm just telling myself. But I was going to write left -1 and plus calculate bounding box of the top. Whatever, calculate ... right? So that's what I was going to do, but as you saw, that would have given me the wrong answer, right? So what we want actually instead is we want to try both of these, but only if left is equal to 3, so it's a little bit awkward, I think. How do I want to write it? Yeah, I mean, I think just another for loop, right? Let's just say for t for in top in range of left. So if left we start with 3, then it goes from 0, 1, 2. Doesn't make sense. So we want 1 on the top, right? So then now here we go t as in that's how many we have, plus go of. Oh, I mean, okay, this is actually wrong. It's going to be left minus t for slicing, right? Because the top half is actually 0, 0. And I'm just trying to visualize it without drawing. But the bottom right, if we chop up there, is going to be, well, where we went. So I plus I, is it I plus 1 or I? It's inclusive, so let's keep it I and y2. Right? And this is not 0, 0. I messed up. It's x1, y1. But I think inclusive this is right, and then this is t plus this, right? And then now we have best is equal to its minimum, so let's call it infinity. We are going to do a lot of these things, so let's already put f min is equal to right? And then now we could do best is equal to f min best of this abomination, right? And then our base case is not 0 anymore. Oh, not only 0. I guess it could be 0 if we only take 1. But no, because if we have 1, then we have this base case, which we'll do. And we'll do the math, but you know, whatever. Just for now, we'll put it slice off the left, right? It's very confusing because I use left as in like how many we have left versus in the left. But in any case, yeah, so then now for I in range from y1, y2 plus 1 to keep it inclusive. I could type it correctly. And then same idea, right? We cut t off to the top and left minus t to the right. Same thing here. I'm trying to. Oh no, yeah, no. Okay, no. This only works. So because if left is minus 2, then yeah, okay. Then this will always only be 1. And then okay, yeah. I'm just worried about off by 1. It's a little bit maybe premature. Okay. So we want t on the left side. The left side is gonna be x1, y1 as the top. Bottom is going to be x2i to keep it inclusive. I may be off by 1 on some of these, but that's fine. I think in a general idea sense, I think we're okay. Yeah. Oops. I think that's mostly fine, right? And then now, yeah, I mean, now we just have to calculate the bounding boxes for this one, and that is going to be a pretty simple, basically what we did yesterday. Am I lazy? Yes. Wait. I guess I am very lazy. I really. I think one thing someone did leave in the comments, and yeah, I mean there is this part where is at least one in the grid, so I didn't have to check for it. But I was like, yeah, well, I mean I saw that I think, but this one we do because it may be that there's zero things in the bounding box, so we have to kind of be a little bit careful. But otherwise, this is mostly okay. We want x1 to x2 inclusive, y1 to y2 inclusive. Remember this gets cached, so we don't have to worry about it that much. We have this, yeah. But if we have, so if max, should it be 0? Maybe I'm wrong here too. I guess if there's one, it doesn't matter. But maybe this should be negative infinity. Whatever, it doesn't really matter. I can just check the other one. If this is equal to infinity, then we haven't seen any. Then we just return 0, right? Because then now basically it's saying that this I keep saying triangle. This rectangle doesn't have anything in it. All right, let's give it a quick spin. I was hoping that we were right, but I don't know how this became an I think I just got confused. All right. I mean, I don't think these test cases are good enough to say that I'm confident, but I am willing to YOLO. And it might time out just because it is Leetcode, but look, there we go. Yay. So what's the complexity here? I think we already mentioned it, right? but that complex, well, we mentioned the framework of it. Of course, it's not sufficient because then now we can actually do an analysis. And here, as we said, x1, actually, I mean, I think this is a little bit tricky to analyze for the things that we said, right? And because if you do it naively, this is going to be less than 30. I'm lazy, so I'm just going to even write and I know that you can maybe divide that by 2 instead because it's choose 2, and these two always have to be smaller than these two. So there is a little bit of a restraint there. And of course, left is less than or equal to 3, right? That adds a little bit to it. But again, as we said, a lot of these states are actually not possible because of the visualization that we did, right? Okay, I already took that out. But you know what I mean is that one or two of these have to be a corner, right? Because we cannot make a rectangle that's interior. So yeah, one or two of these has to be in the corner. So it's not actually the full range is not possible. So that's why the complexity works. Because as we said, I mean, we already did it in the, I guess I shouldn't have erased it, but with the corner thing, if you have one number in the corner, then you only have, 30 times 30 for the other cell. If you have two numbers in the corner, then you can only move even once, right? So as a result, the aggregate, you could even say the amortized total cost is going to be adverse. There's only going to be 90 square, which is n square, or r times c square, or r times c parentheses square, right? Times left, which is 3, that didn't change. And yeah, and so that's what all these things kind of factored in as well, because it's just another 30 on top of that. So the number of possible rectangles is only at most 900, right? All of 900, their rotation, etc. And then each of those, you times that. That's why it is relatively fast. Yeah, and this one is just it's the bounding boxes of all the possible rectangles, which again it is going to be with one corner is only 900 of them. So if you just do the summation of that, that's going to be 900 times another 900, and that's even if you times it by 4 for rotation or something like that, because and you times it by 4 for rotation because then the corner in which is fixed is rotated, right? Then at worst you have 900 times 4, right? And that's it. Tough one for sure, but yeah, I think a lot of the hard work is on the analysis, right? Clearly, because if you look at this, actually, I'm pretty happy of this code, right? Like it's like 40 lines of code, and a lot of it I probably could have, you know, tightened up if I have to. I'm curious what I did last time. Apparently I did it. Oh, huh. I did it in a much faster way last. Oh no, I just converted to Java. I was like, oh, 420 milliseconds. That's way fast, but I just converted to Java. I am like twice as fast this time versus last year. What did I do last year? Oh, I guess I just wrote like a. Why did I wrap this in this? I mean, it is much cleaner. Maybe I did it for explanations, but oh. Oh, I guess this is just much more brute force and not DP. I mean, yeah, I think the idea that I think this idea is just from the idea of the, and I already deleted the message or the image, but it is just based on that idea of kind of case analysis, which, you know, clearly is fine. And I guess that's why I have a container thing, because then it just puts it into the right place for the checks. But you can see just like all the brute forces things, and there are not that many possibility. Yeah, and then you do the rotation version of them. Okay. Yeah, I mean, I think I like today's. I mean, I like the way that I did it today better. So I guess I was wrong. You can improve on things. It wasn't even that long ago. I guess that was a year ago, so that was that long ago. But anyway, that's all I have for this one. Let me know what you think. Thanks for watching. And yeah. Have a great weekend, everybody. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.